We call them hunter-gatherers. Two words, and between them they're supposed to cover almost everything our species did for 200,000 years. Hunting, gathering. Nobody says fisher-gatherers. It is not even a phrase. Nobody has ever needed one. And yet, for an enormous number of people, in an enormous number of places, fish was the thing that actually fed them. Not a supplement, not a bad season fallback, the staple. Day after day for thousands of years, on coastlines and rivers all over the world. So why is it not in the name? The answer is not that fishing mattered less. The answer is that a spear point is a rock, and a fish trap is a bundle of sticks. This episode is about the most important food source in prehistory that we almost cannot see, and about how the picture changed twice because of two very unglamorous things: a sieve and a chemistry test. Neither of them sounds like archaeology. Both of them rewrote it. Start with why hunting looks so big in the record. A hunter leaves stone behind. A flint point survives 100,000 years in the ground without complaint. It is hard, it is distinctive, it is obviously made by a person, and it turns up by the thousand. You can put it in a museum case, and anybody walking past understands it immediately. The animal leaves bones, and a mammoth bone is the size of your leg. You're not going to miss it. Then somebody paints the hunt on a cave wall, and the whole thing becomes a story about men and large mammals. Now to do the same for fishing. A net is made of plant fiber. In most soils, it is gone within a season. A fish trap is wood. A weir is stakes driven into a riverbed, and the river takes them. A line is cordage. A float is bark. A hook, for most of history, is bone, shell, or a thorn. Every single component is organic, and the ground eats organic things. We went through this in the episode on hunting, and it is worth repeating. Nets, snares, traps, and fish weirs are all fiber, wood, and cordage. None of it survives. So the entire toolkit of fishing is made of exactly the materials that rot. And there is a second problem, which is worse, because this one is our fault. Fish bones are tiny. Which sounds like a small problem. It is not. A cod vertebra is a few millimeters across. Many fish bones are smaller than a grain of rice. And for most of the history of archaeology, we did not use a fine enough sieve to catch them. If you shovel your excavated soil through a 1/4-inch mesh, which was normal for a very long time, the fish simply falls through. You're left with the big bones. Deer, cattle, horse, which are exactly the bones that were going to survive anyway. Then you write up a site and report that these people ate large mammals. And you are not lying. You're describing your mesh. This is not a small correction. It changed entire regions. When archaeologists went back and re-excavated sites using a 1 or 2 millimeter mesh and water to wash the soil through it, fish appeared everywhere. Sometimes fish that had been recorded as absent turned out to be the single most common animal on site. The classic demonstration is boring and devastating. Excavate the same deposit twice with 2 different meshes and compare. The coarse mesh gives you a hunting site. The fine mesh gives you a fishing site. Not a change of emphasis. A different economy. Same dirt, same people, different answer. So a great deal of what we thought we knew about ancient diet was, in a very literal sense, a property of hardware. The past did not change. The equipment did. And once you know that, you want a way of asking the question that does not depend on which bones you happen to catch. There is one, and it comes from chemistry. When you eat something, you build your own body out of it, and your bones keep a record of the ingredients. Specifically, the ratios of 2 pairs of isotopes in the collagen of the bone. Carbon-13 against carbon-12. Nitrogen-15 against nitrogen-14. You do not need to follow the chemistry. You only need to know that the numbers come out differently depending on where the food came from. Marine food and land food sit in clearly different places on that chart, because a marine food chain is longer and starts with different plants. So you take a fragment of human bone, extract the collagen, and the bone tells you roughly what proportion of your protein came out of the sea. The person cannot lie to you. The excavator cannot bias it with a sieve, and the fish do not have to be preserved at all. And when this was done along the coasts of Mesolithic Europe, the results were not subtle. People living on the coasts of Denmark, Britain, Portugal, and Scotland were eating a great deal of marine protein. In some individuals, it is most of the diet. Fish, shellfish, and seal, doing the work that we assumed was being done by deer. These are the people we file under hunter-gatherer. They were, to a first approximation, fishers. And it is much older than the Mesolithic and much more skilled than people assume. Go to a cave called Jeremali on the coast of East Timor. It has been excavated, and the fish bone in it runs back 42,000 years. That in itself is old, but it is not the surprising part. The surprising part is which fish, because they are not the easy ones. Among them are tuna and other open water species that do not come close to the shore. You do not catch a tuna by standing on a rock with a stick. A tuna is fast, heavy, and a long way from the shore. You catch it out on the water from a boat, using tackle strong enough to hold something fast and powerful that is trying to leave. Which means that 42,000 years ago, people in that region had boats, lines, and the skill to use both out of sight of the bottom. We know they had boats anyway, because getting to Australia required them, and we did that episode. But there's a difference between crossing water and working it. The same cave produced a fish hook, made of shell, somewhere between 23 and 16,000 years old. It is one of the oldest hooks anybody has found, and there are comparably old shell hooks from Okinawa. Which tells you the hook is not some late refinement. It is deep in the toolkit. And a hook is a genuinely clever object when you look at it properly. It has to be small enough to hide, strong enough not to straighten, sharp enough to set, and shaped so that the pull tightens the grip instead of releasing it. That is a lot of design, worked in a shell with stone tools. And it has to be done again every time one snaps. But the hook is not even the impressive part of fishing. Because the biggest fishing technology is not something you hold. It is something you build. A weir is a fence in the water. You drive stakes into the bed of a river or an estuary, weave them, and leave a gap. The fish move with the tide or the current, meet the fence, follow it along, and end up in the gap where a trap or a basket is waiting. And then you go away. That is the beauty of it. It fishes while you sleep. It runs on the tide, and the tide does not need feeding. It is not a tool. It is an installation, and it turns a river into a machine that catches food on your behalf. Under the streets of Boston, there is one of these. When they were digging foundations downtown, they hit thousands of wooden stakes driven into what used to be tidal flats thousands of years ago. Not dozens, thousands across a very large area, maintained and rebuilt over centuries. That is a construction project carried out by people we describe as mobile forgers. And they came back to it year after year to repair it. And the clearest example anywhere is in southwest Victoria in Australia. On Gunditjmara country, at a place called Budge Bim, there is a landscape of stone channels, weirs, and ponds built to manage the movement of eels. Not one trap, a system cut into volcanic rock, redirecting water across the country to hold and harvest fish. Parts of it are at least 6,500 years old, which makes it older than the pyramids. It is on the World Heritage List, and the Gunditjmara people are still there and still connected to it. And it does something quite important to the standard story. Because the textbook says that permanent structures, storage, and settled life arrive with farming. Budge Bim is permanent infrastructure built by people who are not farming to manage an animal they did not domesticate. The thing that made people settle down was not always grain. Sometimes it was fish. Staying put does not require a crop. It requires something reliable that turns up in the same place every year. Which brings us to the strangest fact in this whole subject. Because after all of that, a great many people stopped. Along the Atlantic coast of Europe, at the point where farming arrives, you can watch the isotopes change. Before, heavily marine, coastal people, eating from the sea for thousands of years. After, almost entirely terrestrial, land animals, land plants. And it happens fast. In some places it looks like a generation or two. That is not a slow drift in taste. That is a switch being thrown. These are people who did not move. They stayed on the same coast, in sight of the same water, with the same fish in it. And they appear to have simply stopped eating them. Now, this reading has been argued about, and it should be. Some researchers think the shift is sharper in the chemistry than it was in real life. But something changed, and the change is not about availability. The fish were still there. Something else moved. And whatever moved, it moved inside people's heads. Perhaps it is about what counts as proper food when you have become a farmer. Perhaps the new economy simply did not leave time to go out on the water. Either way, it is a reminder that diet is not just calories. It is identity, and identity can turn a food source off. So pull it together. fishing was probably feeding more people in more places for longer than the hunting we named ourselves after. It leaves almost nothing behind, because everything it uses is fiber, wood, shell, and bone. The bones it does leave are so small that we sieve them out of our own evidence for a century. When we finally look properly, with a fine mesh and a mass spectrometer, whole coastlines turn out to have been living off the sea. And the largest structures some of these societies ever built were not houses or monuments. They were machines for catching fish. We call them hunter-gatherers. That name is not a description of what they ate. It is a description of what happened to survive.